Well, let's turn our attention to algebra with two unknowns. And let's start working up this column about graphing. So let's go to point and slope. Now, I've always found that students are confused when it comes to slope in several different ways. We spent a lot of time trying to help you locate points on a graph grid, and then we start talking about slope, and you get finding points and slope mixed up. So I made this little cartoon, sort of copying some other cartoons, but I made them into like track stars, and I hope that this will put a hook in your memory so that you can not make the mistakes that your predecessors have made. And I have the one athlete saying you have to rise, because this kid's sleeping, before you can run. Rise means up and down, and run means horizontally. So let's do a new problem. Now, we did get an undefined slope. We would. First thing, it's not the first thing I want you to do, but undefined. There are two kinds of slopes that are sort of unusual. There's a horizontal line, and it has a slope of 0. Like if a road out in the Midwest, like in Kansas, the roads are straight, flat. There's no slope to that. Gas mileage, it's easy on them. But you go to San Francisco, some of those roads are nearly perpendicular. At least that's the way it struck me. They weren't really, but they were very steep. And if you can imagine a road that went straight up, that would be impossible for you to ride on. That would be undefined. So a slope of 0 is a horizontal line, and a slope that's undefined is a perpendicular line going straight up, perpendicular to the x-axis. So we want to click the mouse that forms on a point that forms an undefined slope with the red point. Well, that would be anywhere along here, so I'm going to do that. And it says find another one, so I usually like to do one on one side, one on the other. There is a line that passes through them is undefined slope. I don't know why. It's darker, slightly darker than the rest. I intended it to be darker than that, but I must have darkened the grid. Let's do another problem. Click the mouse on a point that forms a slope of 3 halves with the red point. Now there are two mistakes that students make. One is sometimes they count slope from the origin, which is wrong. We want to make the slope count from we want a line that forms a slope with this red point, so we need to count slope from here. And a slope of 3 halves. The 3, you have to rise before you can run. The 3 is a rise, and the 2 is a run. So I want to rise 3, 1, 2, 3, and run 2, and there's a point. There's a slope of 3 halves. Now it says you're correct, but find another point on the same line. Now, since I'm talking to you, I want you to see how we could find another point on the other side of this red point, which forms the same slope. Look at this slope, 3 halves. If both the numerator and denominator were multiplied by -1, that would be really multiplying by -1 divided by -1, which would be a 1. So -3 over -2 is still the same slope. So if I sink down 3 and go backwards 2, I'm on the same line. So here's how you can get 2 points. We could have gone rise 3 and run 2. Again, we could have gotten any of these points belong on the line. I hope you can see that. Let's do another problem. Oh, another 3 halves. Click the mouse on a point that forms 3 halves. 1, 2, 3. Rise before you run. Sink before you can go back. New problem. A point that forms an undefined slope That's any point along this right. New problem. Another undefined. Good grief. Somebody must want you to understand. But the line is just barely dark. I need to probably make that darker. -5/2. So you've got to rise before you can run. We want to rise -5. That would be sinking 5. 1, 2, 3, 4, 5. Over a run of 2. Now find another point on the same line, and we could keep going on down this way, or we could go backwards. Think of both of these being multiplied by a negative. That would be 5 over -2. Go up 5 and backwards 2, and we get I think it's probably best for practice to surround your red point with something in each direction so that you get used to being able to count the slope out in either direction. A slope of 0, that's the roads out in Kansas, and you can click any point along here. Slope of 0, as opposed to a slope of undefined. Slope of 1/2, rise before you can run. 1/2. You could go 1/2 again, or you could go down 1 and backwards 2. New problem. Slope of -3. Well, -3 isn't written as a fraction, but I can write it as a fraction. -3 is worth the fraction -3 over +1. So we will rise -3 and run 1. Or we could rise 3 if we went backward 1. I hope you see that. Oops. It yelled at me because I clicked a point that wasn't on there. Slope of 0, easy. 5/3, rise 1, 2, 3, 4, 5, 1, 2, 3. I can't rise another 5. I'm going to have to go sink 5 and go backwards 3. 1, 2, 3, 4, 5, and go backwards 3. And get that. Sometimes you see being able to do the opposite numerator and opposite denominator and keep the same slope helps you when you get too close to the edge of the graph grid that they give you. Slope of 3, write it 3 over 1, rise 3, run 1. Or sink 3 as long as you go backwards 1. Look, we've gotten 12 of these right already. It's kind of easy. Undefined, undefined. You're in San Francisco trying to drive straight up some of those roads. No, you're not in San Francisco. None of them is that perpendicular. They just, to this Ohio-born, Ohio-raised girl, the streets in San Francisco seem very steep, and the streets in Kansas seem very unsteep. So, slope of -2, write it as -2 over 1, sink 2, run 1, rise 2, and go backwards 1. I've been doing them all right, so let's see what happens when we do it wrong. What if we click someplace? It's just going to yell at you until you get it right. Slope of -1/2, down 1, rise 2, run 2. Or upward 1. If I change this, I'd have to go backwards 2 and stay on the line. Hope you see how to do that.